Let's implement the function pixels from corner, which takes a posin that we think of as a position on the screen and has some number of pixels over and some number of pixels down, and pixels from corner will tell us how many pixels we have to traverse to get that far. Let's follow the design recipe. So we start out with the data step, and of course pixels from corner tells us that we want to deal with positions, so a posin is a good choice. We could just write down a posin is to remind ourselves. Make posin num num. Right? But the decision that we're going to use posins as the input of our function is the first step of the design recipe here. Now we can move on to contract purpose and header. The function, as the problem statement gives us, is pixels from corner. So our contract is pixels from corner. We decided in our data step that the function would take a posin, and it needs to return the total number of pixels to move down. So that sounds like a number to me. That's our contract. To compute the x offset plus the y offset is our purpose statement, and the header is pixels from corner takes a posin p. That's our contract purpose and header. Moving on to the example section, we want to show what will happen when this function is done. So we write check expect, right? Because we're writing a test, then we have to write an open paren pixels from corner. This is the only way that a test for an example for pixels from corner can start. And the only way it can continue is, according to this contract, we have a posin next. How do we write down a posin right here? Well, we have a data definition that tells us a posin is open paren make posin, and then we get to pick two numbers, like 3 and 4. Close paren. So that part in gray is the posin that the contract says we have to provide. Close paren. So there have been only the choices of 3 and 4. Everything else we had to write as we did to write an example here. And then what do we expect to get back? Expect to get a 7 in that case. We could write another example, and if we do, again we have to write check expect pixels from corner make posin, and now once again we have a choice. We can pick whatever numbers we want, and those numbers add up to 13. So that's our complete example section. Now for the templates step, this is the newest step, which says if we have compound data as the argument to our function, okay, is p this argument compound data? We can check the data definition for posin. A posin is make posin. So that make there says yes, it's compound data. It has two pieces inside of it. So we write a selector that pulls out the two pieces, each of those pieces from p. And we just have to know that make posin has these functions posin x and posin y that pull out each of those two pieces. Right, so posin x p and posin y p are here because the contract says it's a posin. And we have p because that is the argument from which we are extracting those pieces. Right, so this part, this template step, there was no creativity. That's the only right answer for the template right there. Okay, so I'm going to make a copy of the template, mainly so I can save it. I'm going to comment out with semicolons the template, and now I'll keep working on this in the body step. Okay. So the body is, well, finish it up. And I finish it up using my examples. So here I have pixels from corner make posin 3, 4. What does posin x produce in that case? It produces a 3. And posin y, it produces a 4. How can I combine the 3 and the 4 to get 7? Well, of course I should add them. Right. And I could check with my other example. Posin x of p in this example will be a 10, and posin y of p will be a 3. 10 plus 3 is going to be 13. So that looks promising. Our last step is test, to actually run our examples. So we run them, and all of our tests pass. So that is the complete implementation of pixels from corner. Let's try another one called flip posin. Takes a position and flips it over the diagonal. So for our data step, Again, the problem statement says position. It practically tells us we have to deal with posins, so we're going to just use our data definition reminder right here as before. Contract purpose and header for flip posin. I'll just hide that bottom window. Flip posin takes a posin and produces what? It's supposed to take a position and flips it over the diagonal, which means it gives us a new position that's flipped. So that means it takes a posin and produces a posin. To produce a posin with p's x and y, but flipped. Right, so flip posin p. That is our contract purpose and header. For the examples section now, we're writing examples for flip posin, so we have to write check, expect, we have to write flip posin, and now our contract says that we want a posin, which means we have to write open paren make posin. And then we get to pick a number and a number, and flip posin has only one argument, so that's it. And then we have to predict the result here. It should be a posin according to our contract. And so it should be something that's make posin. And of course we want 4, 3 to show the x and y flipped. And we can make another example just with different numbers here. -3, 41. We should get 41 minus 3. That's our example step. The template step. Does flip posin have compound data as its argument? We look at the contract here and it says it's a posin, and we look at the data definition for posin and it has a make, and so yes, it's compound data. It has two pieces, two numbers that we want to get out, with posin x from p and posin y from p. That is our template, the one and only possible template for this function. So I will again keep a copy of it. And now we're ready to finish implementing the function. Posin xp in this first example is going to give us 3, and posin yp in this example is going to give us 4. So we have a 3 and a 4 that we want to put together to make posin 4, 3. So we want them in the other order. I'll flip them around here. Now I've got 4 and 3 that I want to combine to get a make posin 4, 3. And so I just need to put a make posin in front of those. And let's check again for our second example. In this case, posin y is going to be 41. Posin x is going to get -3. And I want to put the 41 and -3 together with the make posin. As the last step, let's run our examples. And all the tests pass. So that was the body and the test, and we're all done.